Welcome to DBT-GA4 Setup, BigQuery Table Types. I'm Damon. In this lesson, we're going to look at the different table types, and for each table type, we'll discuss how does it work, what are the advantages and disadvantages of that table type, and when do you use it. Let's jump right in. Let's take a minute to understand the different BigQuery table types. So BigQuery offers a number of different table types. You have your standard table, partition tables, which is a variation on the table, view, materialized view, which is sort of like a cross between a view and a partition table or table, depending on how it's configured, and then finally external tables. So external tables and materialized views aren't used in the DBT-GA4 package. External tables for obvious reasons, and we're not going to cover them here. Materialized views do have their use, so we will go over them briefly in this lesson, even though they aren't in the DBT-GA4 package. So this here is a diagram of the tables that build into sessions. So this is not a complete graph of all of the tables. So over here on the right, these are your data marts. These are production tables. And so we've got fact GA4 session daily, which then creates fact GA4 sessions, dim GA4 sessions daily, and dim GA4 sessions. Then all of these tables on the left here are the tables that build into these data marts. Data marts you want to use for reporting. The ones on the staging tables on the left, they're kind of like the homework, how you get to here. So these are part of the build process, and we don't want to actually have end users query them. Now here, so you got base GA4 events, which goes into stage GA4 events. Everything goes through these two models and then branches out from here. We've got a few stage session traffic sources daily, last non-direct daily, session properties or derived session properties. If you've configured derived session properties, then session traffic sources, not daily, derived session properties. So we have a daily table here and then a non-daily table here, and then session conversions daily. Now, the tables are highlighted in green here. Then we have views. So these two staging models here are views. And then the vast majority of the tables in here are partition tables. So we're going to look first at the tables. So tables are just kind of like standard tables. So for example, here's a sample purchase table. We have event name, which is purchase, and then value, tax, shipping. Now, the way that analytics warehouses work, which is different from your transactional warehouse where you get one row at a time. So if you're looking up the password of someone or looking up their name, address, etc., you want to get rows, whereas analytics warehouses want to get columns. And this is so that you can do things like this. Count the number of event names, or get the sum of the value of all purchases, get the average tax charged for purchases, or get the highest shipping value. So analytics warehouses, they're optimized for getting columns of data. Now, what this means is it's really fast when getting columns of data. However, you have to get all of the data in a column. Now, this can get expensive if you have a lot of data. Also, because it's designed to get columns of data, changing individual rows is very expensive, whereas a transactional SQL database that you'd build an application on, for example, changing rows is what it's built for. So the advantage is the table is very fast for getting columns, but you have to get all of the data in a column, and you want to be careful about changing individual rows. So here are the tables in dbtGA4. So dimGA4 sessions and factGA4 sessions. The reason we have these in here is because partition tables are partitioned by day. So if a session crosses from one day to the next, it gets counted twice, once on each side of the partition. So these tables are not partitioned to give you an option to have perfect data, although you will have to query all-time data to use them. Now we're going to look at partition tables. So here we have the same table, and imagine that it has event name purchase, and we've got event date. We've got the 1st of May and 30th of April, some values from 2 different days. So in a normal table, this would all just be one big table. In a partition table, if we partition by the event date and partition by day, then that gets split into 2 tables. You have a table for the 30th and a table for the 1st. When you're working with this, so for end users using data viz tools or whatever, they don't know that these are different tables. This seems like just a single table. But the advantage, so it's cheaper to build and cheaper to query because you only need to build the days that need to be changed. Similarly, when you query it, as long as you query only certain days, then you don't need to query all-time data. Now, disadvantages is it's a lot harder to create these partition tables, a lot more attention to detail. Also, when you're querying the partition table, you need to use a where clause to benefit from it. So usually data viz tools handle this for you. So if they're querying your purchase table and you set it up to have a date control between 2 dates, then the data viz tool will add the where clause, and the partition you'll only hit the partitions that you're going at. And finally, these partition tables are really best for large data volumes. Small data volumes can cause performance issues because the standard table is efficient for getting lots of data, and if you're not taking advantage of that, if you only have 10 rows in each table, like you want tens of thousands of rows in each partition. So these are the partition tables in dbtGA4. As you can see, most of the tables are partitioned. So we've got daily partition session dimension and fact tables. And these give you a partitioned option so that you can potentially disable the dimGA4 sessions and factGA4 sessions if you want, if you're worried about the costs of building these 2 larger tables. So these in some ways are optional, and then the non-optional ones we make sure to partition. Now, finally, views. So in this sample, we have a couple of views. So the stage GA4 events and stage GA4 sessions traffic sources. So views are kind of like tables that don't exist. They're like an alias to a query that would generate that table, but the table doesn't exist. So when you're working with a view, what you're actually doing is you're getting the previous table. So in this case, if you query sessions traffic sources, you hit stage GA4 events, but that's a view. So actually what you're doing is querying base GA4 events. So it's presented as, this is presented as if it's a table, but when you query against it, this table doesn't actually exist. You're querying base GA4 events and then just going through these staged transitions. The advantages of views are that they do not cost storage and they do not cost processing to create because the view doesn't really exist. The disadvantages are that they inherit the limitations of upstream tables. So for example, if we go back here, base GA4 events, you're getting all events recorded. So that means you have to search through all events. If you're only looking at page view events, for example, you're still not saving anything by having a view that filters on page views because you're hitting all events regardless. Similarly, grouping and aggregating data is done every time the view is queried. So when you're determining the performance impact, one really simple way is just how many rows am I querying? So if you're trying to group session data, you create a session table. Now, if that session table is a view and you query it, then you're looking at all of every single event, which there are many events in each session, say maybe 8 events per session. So that's 8 times the size it would be if instead of a view you used a table or a partition table where you're grouping by session and there's only one session per visit as opposed to the multiple events per visit. So grouping and aggregating data is done every time a view is queried, which means it's more expensive than if you group as a table and reduce the number of rows, or group as a partition table and reduce the number of rows. Finally, materialized views. So materialized views, they have a very specialized use. So we don't have any materialized views in the dbt GA4 package, but you may want to use them. So here we have what looks like a partition table. All right, we have this partition for the 30th and a partition for the 29th, and you've got some sample rows here and a bunch more, another sample row here and a bunch more. Now say on the 30th, this is a materialized view, and say on the 30th, you query again, and another transaction has happened since the last time this data was accessed. So when you query, the 30th will update and give you another row, but it won't touch the 29th or older data. Now, on the 1st of May, if you query again, then it just adds another partition. And since these tables are the 30th and the 29th are complete, it doesn't rebuild that. So what materialized views are really used for is for real-time data. If you need real-time data, then you use a materialized view. Now, let's say, for example, you wanted your daily session data with real time. So in that case, what you would have to do is change all of the non-view upstream tables to be materialized views so that this gets updated, which cascades to this updating. Well, this goes and it requests this, but which requests this, which these two, which then goes all the way back to base GA4 events, which regenerates today's partition and then flows that back up. So the advantage of materialized views is that it enables real-time data, and it does so in a way that minimizes the costs. The disadvantages are that it is slower because you need to rebuild every time you access the report. You also pay to reprocess partitions each time that partition is accessed. So if someone is sitting on their computer and refreshing the same report 100 times a day, then you're reprocessing those partitions 100 times. Versus if you build once an hour throughout the day, you're only rebuilding it 24 times in a day. Finally, as I said before, upstream tables need to be either continuously updated or be views or materialized views. So if the base table, if this base GA4 events table is a partition table that only gets updated, that got updated early in the morning and only has yesterday's data, then it doesn't matter if these tables are materialized views because it goes back up and this data, this bottlenecks the data. So you need to update continuously or have a view or materialized view. To recap, we looked at 5 different table types: tables, partition tables, views, materialized views, and external tables. We're mostly concerned with tables, partition tables, views, and materialized views. Materialized views are not actually in the DBT GA4 package, but you may want to use them. Tables query all data in a column. They are fast, but they have to get all of the data from that column. You use them when you don't have too much data. Partition tables split tables into multiple copies depending on what you partition on. They are cheaper to build and use, presuming you query them properly, but they're hard to create and are used when you have lots of data. Views are like an alias to a table. They don't cost anything to create or store, but grouping does not limit the data scanned. They're best for infrequently used tables, like when you're building. Materialized views, they build the table on request. The advantages is they enable real-time data with a minimal cost, but they are slow and possibly expensive depending on how they are accessed. They're used for real-time data.